Good day, everyone. So today we have something interesting. I was moving around computer repair shop buying like non-working laptop motherboards for parts because some of subscribers they are asking me, where are you getting spares, where are you getting parts? I'm moving around locally buying laptop motherboards for parts, and I bought like close to 100 laptop motherboards. There are so many motherboards. You can see all these motherboards. We have like two boxes full of motherboards. But you know what? I have a feeling because it's very hard to find people with adequate electronic knowledge. So I have a bunch of motherboards. Trust me, I have a bunch of motherboards. But what we want to do, we want to reevaluate what other technicians did on these motherboards. Maybe we can find one or two motherboards working. Because I bought them like for $30 to $40, like 100 laptop motherboards, different laptop motherboards. So we want to reevaluate the motherboards. We'll see why these motherboards were condemned like to be treated as donor boards. Maybe they are not fixable. We want to fix what we can fix. What we can't, we just move on. Because we did not buy this for the intention of fixing. But I have interest that out of all these motherboards, maybe we can be lucky. Okay? So that's the story. That's what we want to do here. Some they have RAM memory, some they have charging ports. So let me take this aside. We don't want to waste too much time. If we can't fix, we can't. We just move on. So let's start with this one. Okay. And I don't know what model of this looks like an HP. Some kind of HP motherboard. So the charging port is here. We want to test why these boards were condemned. We want to test what do I need? What current do we have here? 3 amps, 19 volts. That's perfectly fine. And it's taking 29 milliamps. Okay. Let's check this board. Let's check this motherboard. So on the plus of the charging port, volts. On the charging port, we have 19 volts. On the current sensor, we have 19 volts. So the 19 volts is present. The 19 volts is present. Here we have 19, 3.3. We have the Novatone startup chip here, 3.10 volts, 3.21. Even the 3.3 is present. So where's the switch? Where's the switch button? Here. We do have the switch button. It's now taking 36. 3.3 on the switch button. You can see 3 point, pressing. I can't see anything. Maybe. Okay. What I want to do, let's unplug the charger. We have 19, we have 3.3. Let's go on diode mode. We want to check the resistance of these coils. 72, 72, 25. So why this motherboard was taken seven ohms for the processor. Okay. You know what? Check this coil. This is kind of new motherboards. If you check on this coil here, because we do have the charging port. Where's the charging port? Here. We have two MOSFETs in serial mode. After the two MOSFETs, this must have the PD controller. Like the coil, which is meant to generate the main power rail, the main voltage. And I believe it's this coil. You see this coil? Something is not right here. Because this coil, we must have something like, this is the coil for the PD controller to generate the main power rail, maybe 16, 12 volts, depending with the laptop. So I don't think something's making sense on this coil. I don't think so. Let's go to 1 volt. With 1 volt is taking. Let's go on 1 volt. Want to see what's going on here. With 1 volt is taking 1.9 amps. How is that possible? Let's take our new baby. I forgot to tell you we have our new baby today. Our new baby just arrived today. This is a thermal camera. We just received the thermal camera today, and I'm not going to use the analog style anymore. Let's try to be pro. Let's try to be pro. We received Unity UTI 120S. That's the model of this thermal camera, which I believe can work fine on this kind of job. On. We want to see what's going on here. Let's inject some power. Maybe you can see what is heating up here. Processor. Or maybe it's on the other side of the motherboard. Because I can, from this end, I can see what is taking that current. So now we need a jumper. We need a jumper. We need a jumper here. Because we just want to know, and we can't access all these motherboards at once. We can't. Because the boards, there are too many. But we need to know only the reason why these motherboards were condemned. Because this looks like we can fix this one. Looks like it's fixable. Now, we want to check the other side of the motherboard. What is that? Huh? What is taking 1.7 amps? You know what? Let's raise the current. 2.2 amps. The processor's code is not getting hot. Those are my wires. On the other side, (31.6 degrees). No, I can't see what is getting hot here. But what I believe was this power supply, we have the charging port, which is, and this power supply here, which I believe is generating the main 19 volts power line. Let's check those capacitors. Yeah, the core is shorted to ground, but we don't care. But it seems like the PD controller is shorted here. This can be fixed. I'll put this aside. This can be fixed, because if we have a good processor, if the PCH is not shorted, we still have chance. We still have chance. Let's check this one. This looks like a Lenovo motherboard. So why this was condemned? We have the charging port here. This is ground. Here we have a short on the second MOSFET. Let me show you. Something is not adding up here. Something is not adding up. Let's go on a microscope. Let's go on a microscope. What do you have here? We have those MOSFETs in serial mode and the charging port. We do have the charging port and those MOSFETs. So if we check on the current sensor, here, we do have a short. This is beeping to ground. So let's see what is shorted. Let's see what is shorted here. I think we can also inject some power and check with the thermal camera. Let's check with the thermal camera what is shorted here. on the current sensor. And what is that? Check here. What is that? What is that? It is a capacitor. Huh? I wish I had a thermal camera all along. Huh? We just found the problem. Maybe we can power it off. Or we can't. Okay. So let's see. Let's see. What is that? Huh? What do you think about this capacitor? Huh? What do you think about this capacitor? What do you think about the capacitor? So let's replace the capacitor. I wish I had a thermal camera all along. This tool is just beautiful. Huh? This tool is just beautiful. And I believe that this looks like a cracked capacitor. The capacitor is out. What about replacing? No time to replace the capacitor. We don't have time for that. You don't have time for replacing the capacitor. You know the everyday story. Every time I'm misplacing my thermal pads just to cool up the heat from the motherboard. Every day. Cooling out the motherboard. Let's see now, 19 volts. 19.36. Need a USB stacking 170, and we have light here. Huh? Really? Let's see if that light turn off when we short pins on the switch connector here. Oh, finish. I think I just cue it. Finish. No light anymore. Yeah, I did something very bad. But let's check. Let's check for some power. Do you have 3.3? 3.38 on the switch connector. 3.33. That means we have 19, we have and the board is on. You can see the light here. We have light. So probably this is a working motherboard. Huh? Don't you think so? But we have a frame to confirm this. We have a frame. I don't know how we can test this. But we need to test just to see if we can see anything on the display. On the display side of the motherboard. I just want to see it's taking 200 and something. What about picture? Let's connect again the cable. Yeah, this looks like a working motherboard. Let's raise the current. Let's raise the current. What current do we have here? 3.6. 3.6 should be fine. But this board is on. I wanted to check for display, but maybe we have a faulty RAM, maybe we have something else. Who knows why we don't have display? Why we don't have display on this motherboard? I changed the RAM. But I think this can be fixed. Disconnecting the power supply. Let's check the CPU, GPU, and other voltages. But this is a working motherboard. The motherboard is on. I want to check all voltages on the coils. 5 volts, 3.3, 0.9 volts, 0.8, 1.35. This is the RAM power supply, 1.35. Here we have 0.9. This is the processor. And here 0.8. That's the GPU. Here we have another power supply here on the charging circuit here. So we have voltage. So probably it's not displaying. Maybe it's a faulty RAM or a BIOS or anything. Maybe. But I'll put this aside. This is giving us picture. Let's go on this one. This is the 30 motherboard. So what is the story with this one? This looks like an HP, some kind of HP motherboard. Light, we don't have any light. On the charging port, we have 19. Where are my MOSFETs? Here. And the first MOSFET is missing. Here we have another missing components. This has got missing components. They took out the components. Let me show you here. You see here. Here, this is meant to be the first MOSFET. Second MOSFET and the current sensor. So the first MOSFET is not there. So what we can do here, we are not going to replace the MOSFET. Let's jump over the MOSFET. Let's jump over this MOSFET. That should be fine. This won't solve the problem. But we just want the 19 volts to pass. Here we have another missing component here. This one, another MOSFET missing. That the ENE chip. Otherwise, the board looks fine. Huh? Sounds cheap. Two main components on this other side. Let's check. So far, and we have light. You see the light? That means the 19 volts is on and the 3.3 is on. So trust me, if I check these boards one by one, out of 100, I'm sure we can fix around a quarter. 10 to 20 motherboards, I'm 100% sure we can fix them. I'm 100% sure. 3.3. Let's try to power on this motherboard. Where's the power on button? Power on the switch connector. I believe is this one. And it's taking 244 milliamps. And the board is on. Huh? These technicians. What do you think about these technicians? Huh? What do you think? $236. The board is on. It's coming on and goes off. Coming on and goes off. I think you know the story. Coming on and goes off. I will check the 5 volts power supply. And the VREC 5 for not being shorted. But this one always has got other missing components. But this motherboard can be fixed. On. There must be a reason why this motherboard is shutting down after some minutes. Diode mode coils. Here, with this behavior, I'll change the driver. I'll start by replacing this MOSFET and I'll put my attention on the 3.3 and 5 volts driver. Let's check the driver together. Where's this driver? On the other side, that small guy there. Why do you think this capacitor is beeping? You can hear the sound of the test meter. So for sure, I'm sure this driver can be faulty, or something on the 5 volts power supply is coming on and goes off. Let's move on the next one. Another one here. This is another one for Lenovo. Another one for Lenovo. Let's see what voltage do we have here. Volts. 18.9. Why 18.9? Somewhere we are losing like 0 point something volts. I'm just testing these motherboards. We are not here to fix. $3.24. So that means this one they reflow the processor. So I don't think there's anything here for us. You can see this plastic is melted here. So yeah, and we have some flux here. They reflow the processor. I don't know why. So I won't bother myself. Another one. This looks like an HP. The PCH is they reflow the PCH. Why? Why reflowing the PCH? 0. How many ohms? 5 ohms. Something is not adding up here. But based on the fact that you can see that they reflow this. Maybe if we go under microscope, we can see what I'm trying to say here. You see all this area around the PCH. They reflow the PCH. So I don't think it's worth to deal with this one. What about this? This looks like a Lenovo. I don't know the model again. BIOS chip. We don't have voltage. Okay. 19 volts. 18.96. We do have the E.T.C chip here, or the controller. Now we are checking for 3.3. I'm checking on the E.T.C chip. We have 18 volts. So clearly this chipset is gone. The E.T.C chip is gone. How is that possible to have like 18.82 volts on the E.T.C chip, which is meant to work with 3.3 volts? So what it means, I explained this thing. We have the 3.3 volts and 5 volts power supply. In most cases, they are moving together. So from the 3.3 LDO or from the 3.3 volts from the VREG 3, we have a shorted there. We have a short and it's sending straight 18 volts to the E.T.C chip. This E.T.C chip, I don't think is alive. So here I'm sure we have two problems. We have to change the 3.3 volts and 5 volts regulator. Let me see. Where is that regulator? Where is the regulator? Where is this regulator? Regulator, where are you? Which chip is this? 3.3 and 5 volts power supply. I'm not sure because we have TPS 512204. Maybe that's the one or something else. But here, if I'm to fix this, I'll change the regulator for 3.3 volts always on, because the VREG 3 is sending 19 volts to the E.T.C chip. And I don't think it's normal to find like 18 volts on the E.T.C chip. I never found something like that. So moving forward, we have this, looks like another HP model. We have the processor PCH all-in-one, AMD graphics chip. graphic memory, Novaton, and it's taking 47. Do you have 19? Do you have 3.3? That is the most important thing. The 19 is there. What about 3.3? What about 3.3? 3.3. Okay. I'm not sure whether these are reset pins or we have a switch connector. Maybe here. What this connector is doing here. Let's see. No. Maybe it's not this one. Maybe it's not this one. Maybe it is this one. And this board, too many components missing. This we can fix this. What about this one? Huh? Which laptop is using this? Is it Dell? Okay. We need the big pin. Because we have a big charging port here. Like for HP. And we have light. Huh? So where's the switch button? Because if we have light, we must have 19 volts, we must have 3.3. Let's see. Five volts. Okay. $1.4. 19 volts. We are just checking some voltages here. You can see we have a flashing light here. 3.10 volts. But this looks like a working motherboard. This looks like a working motherboard. Another one. some old HP. Plug in the charger. We don't have light. Why? I don't know. I don't know why. Let's check for 19 volts. On the charging port. Okay. Where are my MOSFETs? Oh? I'm only seeing voltage here on the charging port. Okay. Let's unplug diode mode. Where this plus is going? It's not even going here. Huh? Where the plus is going? What? We are failing to see where the plus is going. I'm trying to understand this motherboard. Why? Do you have a fault charging port? Why? The thing is, we don't have 19 volts. And I'm trying to understand. Okay. So here it's beeping here. So this is the current sensor. So if this is the current sensor, Let's plug in the power supply again and check some power. The problem, we only have voltage on the charging port. That is the problem. Okay. Yeah, this is making me confusing. So we can jump here. Let's do some dodgy things. Let's do some dodgy things. Because after all, we have to understand that time is the key. Let's do some funny things here. Yeah. Okay. We are not fixing here, but I just want to bring 19 volts on the main power line. Because this board can't power on because the 19 volts power line is missing. It's missing. to the plus of the charging port here. Good. Let's see now. Let's see now. Still we don't have light. Still the light is missing. But we can check for 19. Our 19 is now present. 3.3, we do have a bias chip. 3.29. On the switch connector. 3.28. Let's try to short pins. Maybe we have a fault, BQ chip, we have we don't have light. Yeah, this chip is getting warm. Something's wrong here. Let me show you. Something's not right here. You will see. Something's getting hot here. You see here? It is taking 75 degrees Celsius. And that chip is getting hot. I think that's the problem. Let's see what chip is this. That's the chip. Which chip is this one? Five one one 2 3. This is the 3.3 and 5 volts regulator. It's gone. It's gone. This regulator is gone. It's heating up because why this regulator is heating up? Okay. So I think if I'm to fix this, I'll change this TPS 51123. You can see on the thermal camera, it's taking that current. It's some kind of watt. Huh? If you check on the thermal camera, that chip is super hot. It's taking that 68 milliamps. It's warm. So this one is fixable. Should not be condemned. The idea of this video is to see the motherboards which must be condemned and the motherboards which can be fixable. This one, I'm sure, can be fixed. There's no reason to condemn this motherboard. Let's do the last one. Let's do the last one. This one. I need a better one. Maybe this. Or we'll have another one for Lenovo. Let's see this Lenovo. This one. This is another one for Lenovo. We need a charging port. Lenovo charging port. The pins, they are not straight. Fine. Let's see the Lenovo one. $35. Do you have 19? Do you have 3.3? So out of the boards that we managed to check so far, most of them, they are fixable. Current sensor, 19 volts. Here we have a chip missing. 3.3, that's the 5 volts driver. The 5 volts driver is missing. Let me show you. So I guess that was the problem of this motherboard. You see that chip here is missing. This one is 3.3, this one is 5 volts. And you have a chip with MOSFETs inside. So this one can be fixed. I need to just one more for the rods. One more for the rods. HP. Where can I get the charging port for this one? We need an HP charging port. Maybe let's try this with the charging port. Was on the HP, I can't see the charging port. Is this the right chip? Let's check some power here. We have 19. The second MOSFET, they took out the second MOSFET. Let's go on a microscope. The boards, they just have some chips missing. I don't know why. What is missing here? It is the second MOSFET. I think we can jump this. We can jump this. Good. This is supposed to be the gate, right? Fine. We just jumped the second MOSFET which was missing, which was taken out for the reason which we don't know, and it's taking 24 milliamps. Let's check for 3.3. 3.3. We can check straight on this connector. Five volts. What about 3.3? On the Novatone. Okay. 3.28. Pressing the power on switch. And the board is not turning on. What about with the tweezer? Shorting pins one by one. Any change of current? Do you have the BIOS battery here? Oh, the BIOS chip is missing. Ah, I told you these people, huh? They were checking components. Check here. This is place meant to have the BIOS, and the BIOS chip is not there. So there's no way we can power on this motherboard. They took out the BIOS chip. They took out the BIOS chip. So I'll look for some model of this board and I'll try to put a BIOS chip there. Okay. So let's do the last one. Let's do the last one for this HP. Let's do the last one. Let's assess the last one. Let's do the last one. Let's do the last one and then we conclude about what you see. I need your opinion. What do you think about these motherboards? What do you think about these motherboards? We need a chip for HP. Where's that chip? Where's the HP chip? Let's do the last one. I found the charging port. Plug in the power supply. And we have orange light. Okay. Let's check some power. If we have light, it means we have 19, we have 3.3. That is very clear. But we can just confirm that. The 19 volts is present, 3.3 on the switch connector. So let's short these pins to ground. Pin number 1. No, we are looking for change of current. Change of current tells us that the motherboard is now on. Pin number 2. I can't see anything here. Again. No, it's not working. But if this board has light, is this a crack on the processor? I think here we can't do anything. But the board is on. It's now taking 186. Let's check some voltages. Here, if this board is coming on, I'm sure we might face problem with the display. I will show you why. But let's check some voltages on coils. One volt, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 5 volts, 3.3. The board is off. Because if this board is on, we must have RAM voltage. So what is taking that 180? This is a dirty processor. That's why here we have orange light. Here it's not supposed to have orange light because there's no battery inserted on this motherboard. So I'm sure. What do you think about this? Huh? This is the processor. This processor has got a crack and it's gone. This is the only board that I saw. I think we tested close to 10 motherboards and we found one board with dead processor for space. I think you can see the crack on the processor. You see that crack? Here, it's cracked here. Processor has got a crack. You see the crack? That is the reason why we have 180 milliamps and the processor is getting hot. The processor is gone. It's gone. But these are some kind of faults which can be hard to see with naked eyes. So I think this too is necessary. But if we check on the channel, I think we made something like 300 something videos fixing short circuit motherboard without thermal camera. So don't feel offended if you don't have one, but definitely you need one in the future. Why am I saying so? Because we have those short circuits with a very, very low resistance. It's taking just a little bit of heat, and if you inject voltage, probably you can't see anything, but here it's visible. Here it's visible. It's visible here. Because the moment when you press the on the switch, the board is trying to power on, but because of a faulty processor, you can't do anything. You can't do anything. So I'll stop this video. The idea of this video was to evaluate what other technicians they are condemning. What they are condemning. Because if you are someone who is in repair business, don't trust any job from another technician. You have to re-diagnose the board and get that satisfaction. Because I'm sure all these boards that were assessed, I'll fix them and sell them at with better money. I'll fix them one by one. If I get time, I'll fix them one by one. But yeah, that was the story, and I'm very proud of this model of thermal camera, thermal Yeah, thermal camera. I'm very proud of this. It makes the job easy. Not only that, it saves time. The more you are trying to hunting for short, you are doing this and this and this and this. At the end, you spend too much time. But this is highly efficient. You can save time with this thermal camera. This is quite a nice tool. So this tool came in today. I ordered on AliExpress. It's less than $200. And if you check on my microscope, I add something more here. If you check on the microscope, check how this microscope is now displaying. If you check previous video, there were no clear pictures like this. What did I do? I ordered an anti-glare light. You can see these ones pointing downwards. This is called an anti-glare light, just to get rid of the reflection. Because with the microscope, this ring light, probably you can't get the best quality. But if you can check here, you can see this is a capacitor, this is a inductor, this is a MOSFET. It's quite fantastic. I'm very proud of this anti-glare light, which is responsible for taking out the glare and some reflection from the microscope image. So like, subscribe, don't forget to turn on the notification bell for future updates, and take this video as informative, just to learn the proper way of diagnosing laptop motherboards. You must check for 19 volts, you must check for 3.3. Before you condemn motherboard, you must check all the necessary steps. So see you on the next one. Bye.